Okay, so hello everyone, welcome to Euron. And guys, in this chapter, so we are going to talk about inbuilt data structure called as list. So there is something called as list, there is something called as tuple, there is something called as sets and a dictionary. So one by one, we are going to see all of these data structure. We are going to use all of these data structure throughout our lifetime, not just in this particular lecture. And so let's get started, guys. Let's get started. And let me share my screen. I believe my screen is visible to all of you. So let me just go and create a very simple, very first data structure for all of you, which is a list. So how we can create a list? So just by doing this, I will be able to create a list. So I'm going to define a variable name over here, as you can see. So I'm going to define a variable name, and then I'm just going to say a a square bracket, by the way. Now, if I'm going to check what is the type of this L, so type of this L is by default, Python is able to recognize as a list. Very simple. Now, what I can do with this list, by the way, this is technically a data structure. So what I can do, I can try to store any kind of a data that I want. For example, if I'm looking for like an integer storage, if I'm looking for maybe a floating point storage, if I'm looking for maybe a complex number storage, if I'm looking for maybe some sort of a Boolean value storage over here, if I'm looking for maybe like some string, for example, my name storage over here, I can try to store it inside this list, as you can see. So you can store only integer, only float, only Boolean, only string, whatever you want, or maybe a mixture of each and everything. That's completely fine. You will be able to store it and you will be able to perform all sort of operations on top of this one. Okay, now, so whenever Python is going to store anything inside a list, so it is going to follow almost a similar kind of a philosophy. Not exact same, but yeah, so little bit it's same as a string. So here it is going to give a forward indexing and it is going to give a backward indexing. Forward indexing means start from 0, 1, 2, 3, 4 and so on. Backward means -1, -2, -3, -4 and so on. So it is going to follow the backward indexing. It is going to follow the forward indexing. Now, what does that mean? This means that whenever I have to do an indexing operation, just like a string, I think I already talked about a string slicing and a string indexing operation, a scaling concept as well over there. So whenever I would like to do a string indexing operation, whenever I would like to do a string slicing operation, I can do it. Similarly, so I can try to perform a list indexing operation and list slicing operation as well. For example, so if I'm looking for some data from a 0th index, I can get that data. Let's suppose if I'm looking for some data from maybe like a last index, I can get some data, right? From 0th index, I can get the data. From last index, I can get the data. Let's suppose I'm looking for a data starting from 1st till 4th. Okay, that's great. I can do it. So start from 0 till 4th means 5 I will give. A start point, end point. Yeah, I can get the data. If I'm looking for maybe a alternate data, I can get that as well. So start from 0, then go till like a 8 and then do what? So maybe do the find out the alter data, right? 2, I can get it. So this slicing operation, the indexing operation, which I'm trying to perform over here, you will not be able to find out even a single differences over here. Not even the single one over here. It's exactly same means literally it's exactly same that you all are going to find out. Okay, that's amazing. So this is something that I will be able to find out in terms of indexing slicing. So I'm not going to talk about again index slicing. I don't want to like kill your time as we have already talked about it and as we understand each and everything. Now list of, if I have to do like a reverse, just like a string reversal operation, I can just write like a colon -1 and it is going to do like a reverse. It's a temporary reverse, obviously, unless and until I'm not going to do a list is equal to this, it is not going to override. But yeah, it's a temporary reverse. I will be able to do it. Fine. That's great. Now, let's get into a little bit of like a deeper of this list. So let's suppose I have created this list and I have to extract the data one by one out of this list. I can do it. I can do it with the help of indexing operation, but I can even iterate over to it as it's a iterable object. So I can say like for I in L, for I in this list, print what? So print basically like all the values of this list, maybe like a I can say over here. So it will go to the list one by one, and this is what for loop does. We have already talked about for loop, right? So this is what for loop does. So one by one, one by one, one by one, it is going to extract all the information. It is going to extract all the data, and then it is going to give it to you. Very simple. Yeah, very simple. An amazing way, right? So it is going to give you the data, as you can see. So all of these data has been lined up over here. Okay. Now let's suppose if someone is asking me that try to extract only a integer data out of this list, not floating point, not a complex one, not a Boolean one, not a string one, but only and only a integer data I have to extract. Now, how I will be able to do that, by the way? So here I can write for I in L, and then I can write a condition that if, right, if type of I means the data that we are extracting one by one, which is available inside I, temporary variable, right? So type of I is equal to integer int, right? Type of I means data type, right? Print, then only print I, then only print I. Okay, bingo. I'm able to extract a data whose data type is basically integer. So I'm able to apply a filter operation. That's completely fine. If someone is asking me a question that out of this integer, right? Out of this integer, give me only those data which is greater than 3. I can write that as well. So maybe I can write and over here that match this, and then this, then give me the data. So I can write and then I can write that type is integer and I value is greater than 3, then only give me those data. Yes, I'm able to filter out. So I can write any kind of a condition, any big or small condition on top of this list operation which I'm trying to perform, and I will be able to get a data in no time. Yeah, in no time I will be able to get the data. Okay, that's amazing. That's great. Now let's move ahead. So I'm able to perform the iteration operation on top of this list. Now there are a lot of inbuilt function you will be able to find out inside the list. For example, if I'm going to like show you, so there are multiple inbuilt function, right? Append, clear, copy, count, extend, index, insert, pop, remove, reverse, and sort. All of these operations we are going to see one by one, one by one. Let's try to understand it, because all of these operations, like not all I would say, but yeah, some of this operation you will be able to find out even inside a set. Some of these operation even you will be able to find out inside a dictionary. Okay, so let's do one thing, guys. Let's try to start with the append operation. Now what this append operation does, by the way, append the data in a list, as simple as that. So here I can say that okay, append 56. Now if I'm going to show you the list, it has appended 56. Again, I'm going to call this append, and I just have to talk about something. That's the reason. Euron. And then if I'm going to show you list, so yeah, Euron is here. Simple, right? Euron is here. So append is appending a data where? So append is appending the data at the end of the list. Yes, as its definition says, as you can see on my screen, when you're going to hover your mouse on that function. Okay, now, so append is able to append the information. Append is able to append the data over there. Now there is another function called as insert. Yeah, there is a function called as insert. Now what insert is going to do? So let me hover that mouse, and here, so it is giving you two input, index and object. Now what is the meaning of it? For example, on second index, and on second index, what is the data that we have? 0, 1, 2. So we have 5, right? On second index, I would like to insert my name. So, okay, on second index, I would like to insert my name. And this is what it does. See, on second index, I am able to insert my name. So here you are supposed to give an index and then the data that you would like to insert. If I would like to insert maybe a list inside a list, that's completely fine, acceptable. I can insert it. Okay, there is an extra bracket. So I can try to insert it inside my list. Here it is. On second index, I'm able to insert the data. So rest of the data will be like sifted on your right hand side, basically. Okay, that's completely fine. Now there is another function. So L dot, so append we are able to see, insert we are able to see. Now let's try to see extend. Now what extend does, by the way, hover the mouse. So extend a list by appending an element from the iterables. I'll do one thing. I'll try to pass integer first. Iterables, right? Focus on that word. I'm going to pass integer. Error. Okay. I'm going to pass L dot extend, and I'm going to pass basically my name over here. It is going to work, by the way. Yeah. worked. Now, let me show you what has happened. So see, what extends say is that extend a list by appending an element from the iterables. So it will always try to go through the iterable entity, means a data over which you can try to like extract it one by one, one by one, one by one, iterate through it. So a string is basically iterable. We know that a string is a combination of a character basically, which has been stored into a different indexes. So here, what it will try to do is, so it will try to iterate over to the data, extract one by one out of it, and then it is going to insert it. It is not inserting a string as a single element. It is not inserting my name as a single entity over here. This is what extended does. Now, why it was not able to insert this one? Because integer you can't iterate. You can't run through the integer with the help of for loop. You can't like make it iterables. Yeah, that is the reason. So let's suppose if I'm going to call like a L dot extend over here, and then if I'm going to pass a list inside this one, 4, 5, 6, 7, same thing it will do. It will try to unravel the list, means it will try to extract all the data out of the list, and then one by one, one by one, one by one, it is going to insert the data. It is going to insert the record. Got it? Yeah, everyone? Fine. So hope all of you are enjoying this particular part. Now, so we have like so much of data. So insert, append and extend, we are able to see it. Yeah, there is a difference. Insert means insert at a particular location. Append means last. Extend means only iterables. You can try to insert it at last. That's it. Now here, so list dot, and then there is a function called as pop function. What pop will do? Pop up the data from the last for now. But here, so if you are going to hover your mouse, you will be able to find out a parameter called as index. It simply means that you can try to define even the index over here. For example, L.pop, pop, L.pop, and I would like to pop up the data from second index. Okay, second index. Let me show you L. So this is gone. This data it has removed. Yeah, I would like to like extract the data, pop up the data from second index once again, whatever data we have. So now if I'm going to show you my L, right, this is how it looks like. I would like to pop up the data from like, let me remove the big data, a big one, 0, 1, 2, 3, 4, 5, complex number. So I would like to like pop up the data. So L dot pop, and then from the fifth indexes L. So this is the data we have now. It has popped up all the data that I have asked for. Now there is something called as L dot pop. I can write, and then I can give maybe like 100. Now there is an error because we don't have a data at 100th location, right? We don't have a data till 100th location. That is the reason. So pop is going to give you an error saying that pop index out of the range. Okay, now let me like show you another function. So list dot append, it's fine. Clear I'll discuss in a very last. Clear will try to bypass all the data. That's the reason. So I'm going to discuss clear in a very last. So here extend, insert, and then let's talk about a remove, and let's talk about the difference between remove and pop. Inside a remove, if I'm going to give 100, it's not in a data. Okay, list dot remove, and then I'm going to give maybe a 4 over here. Now what remove is trying to do? So remove is trying to remove the data. So whichever data, we have 4 twice, right? 4 is over here, 4 is over here. So remove will try to remove the data which will appear in a very first place. Yeah, which will appear in the very first place. So remove is removing the data, and if that data is not available, it is going to give you the error. Now, so we have basically count, sorry, not copy. So your unt count. So we have list.count. Now, so what count will do? Simple. Count the occurrences. So how many times we have 5 inside the list? So we have basically like 2 times 5 inside the list. Okay. So this is the reason we are getting 2 over here. Now list dot, and then we can talk about a index over here. So index means, let's suppose I'm giving 5. Yeah. And as we can see that we have 2 times 5 over here. So we have 1 times 5 here and 1 times 5 over here. But this index is going to give you the index as its name suggests. So index is going to give you the index of a very, very first occurrence. It is not going to care about the second occurrences. This is what index does. So here 1. Now let's suppose I'm in a situation basically. So where let me like give 500. Now tell me what is the index of 500. Value error. There is no 500, right? 500 is not in the list. So if that data set is not available, it is going to give you this particular error. As simple as that. This is what index is going to do. Now, so list dot and index we are able to discuss, count we are able to discuss, copy we have not discussed, clear we have not discussed, append, extend, insert, pop, remove. Okay, so now let's talk about a copy. I have a list. Okay, I'm going to create list 1 and I'm going to say list 1 is equal to list, or let me like create a fresh list, guys. So list a small one, 1 comma 2 comma 3 comma 4. Okay, and then I'm going to create L1 and I'm saying that L1 is equal to L. Okay, fine, execute. Now what is going to happen in this situation internally? Yeah, what is going to happen in this situation internally? So internally, right, internally when I'm trying to say this one, it simply means that it is going to reserve the space, and then 1 comma 2 comma 3 comma 4 will be stored, refer as a L, right, this one. Then I'm saying L1 is equal to L. So it is going to refer to the same place, that L1 is equal to L. Simple, right? It is going to refer to the same place. Okay. Now, so it is going to refer to the exact same place. Now what I'm going to do is that I'm going to like say that L of 0 is 1. Yeah, L of 0 is 1. Now I don't want this 1 at L of 0. What I want is I want my name. Okay. Now check L. Now check L. SUDH. So now there is no 1 over here. There is a SUDH. There is a SUDH. I have replaced it. Now let's try to check L1 as well. I have not made any kind of exclusive changes with L1. Right? I have not made any kind of exclusive changes with L1, but still inside L1, you will be able to see the same changes. Whatever changes that I have made inside L, same changes I'm able to observe even inside L1. Very simple, right guys? Everyone? So same changes I'm able to get even inside a L1. Yeah, even inside the L1. Now, the reason is very simple. Both L and L1 is basically referring to the same thing, a same place, right? A same object. Now I'm going to show you something different. And this is where the concept of deep copy and swallow copy comes into a picture. And we are going to use this concept many times throughout my lecture, many times. So here I'm going to create L2, and L2 is what? L2 is L of copy, L of copy. Yeah. Now when I do this, when I call copy basically, so when I call this copy, what happens? So it will not try to refer L2 to the same place. It will try to copy the object of this one, which is technically this as of now. So SUDH and then 2, 3 and 4. I have changed it, right? And then it will refer to the L2. Then it will refer to the L2. Now, let me show you that. Then it will refer to the L2. Now, how it is different from this previous one? How this is different from this one? So now if I'm going to make any kind of a changes in L, let's suppose L of 0, right? L of 0 is SUDH. Now I would like to make it as a this number. Okay. Now let's check L. Things have changed. Let's check L1. Things have changed. Both are referred to the same place. Now let's check L2. Nothing has changed because now both are disconnected. Both are disconnected to each other. Now this particular funda is basically called as what? If you're going to hover your mouse, it's called as swallow copy. SHALLOW. This fundamentals is called as swallow copy. Swallow copy, right? Swallow copy. And the place where we have written L1 is equals to L. So this is called as deep copy. So in case of deep copy, if you're going to change one, it will be reflected on others, vice versa. Right? In case of swallow copy, if you're going to make a changes in one, it is not going to make a changes in the other one because it is trying to create all together a separate object. As simple as that. Okay, that's great. That's amazing. Now, so moving next, our very last function I have to call inbuilt function. So list.clear. So clear is going to wipe out all the data. There is nothing inside the list. Yeah, there is nothing that you will be able to find out inside the list. So this is what clear is going to perform. So hope guys, all of you are able to learn a lot from this particular list, right? all of you are able to learn a lot from this particular list. And going forward, obviously, yeah, so we are going to like learn so many things, so many things I can say in my upcoming lectures, in my upcoming classes with respect to all the other things. So with that, thank you so much everyone. Take care and see you again in my next lecture.